In this example, in Learning Target 3.11, we will learn how to convert between moles and particles. Now the conversion factor we're using is between moles and particles. So we must know that 1 mole is equal to 6 times 10 to the 23rd particles. And again, particles could also mean atoms or molecules. So in this specific question, it asks us how many moles, which is what we're trying to find, of xenon are contained in 24.08 times 10 to the 24th. And we're just going to use the number 24. So we start by writing down our known value, 24 times 10 to the 24th atoms. And then we want to multiply by our conversion factor. And we know that there is 1 mole in 6 times 10 to the 23rd atoms. This is our conversion factor that we identified up here. So if we look at our units, we know that we did this right because the numerator and denominator have the same unit, so we can cancel, and we're just left with moles, which is what we're trying to find. So now, if we simplify this, we have 24 times 10 to the 24th over 6 times 10 to the 23rd. So if we take this, we know that based on academic numeracy, we can simplify this by subtracting the exponents. So taking 24 minus 23, which is 1. So we can simplify this on top as 10 to the 1st. So now we have 24 times 10 to the 1st, or 10, all over 6. And we can simplify 24 over 6 to get 4 on top. And if we take 4 times 10, we get 40. And the units we are left with, again, is moles. So we know that if we have 24 times 10 to the 24th atoms of xenon, or anything, there will be 40 moles. Now in the next example, we actually go in the other direction. It asks us how many molecules are contained in 0.50 moles of C2H3OH. So we always start by writing down our known value, which is 0.50 moles, and then multiply by the conversion factor, which again is 1 mole is equal to 6 times 10 to the 23rd atoms. And we know that in order to have our units cancel, we have to have moles on the bottom, and thus we will have molecules on top. And again, we said that 1 mole is equal to 6 times 10 to the 23rd molecules. Again, our units here are going to cancel, and we are just left with our unit of molecules. And if we multiply across, we get 0.50 times 6 times 10 to the 23rd. And if we multiply these two numbers, 0.50 times 6 would just give us 3, since 0.50 is 1/2. So 3 times 10 to the 23rd molecules. And those are our two answers. Now, as I scroll down here, I want you to take some time to pause the video and do these 2 individual examples. And when you have an answer on your own boxed in, return the video to keep watching. Now, our answer for number 1 is 0.5 moles. And our almost complete answer for number 2 is 12 times 10 to the 23rd atoms. But just remind yourself that this base actually has to be at least 1, but it also has to be less than 10. And 12 is currently larger than 10. So we take our decimal and move it one to the left. And we make that base 1.2. And because we did that, we need to increase this exponent by 1. So 1.2 times 10 to the 24th atoms. That would be the amount of atoms in 2 moles of sodium sulfite.